Hey guys, welcome back to AI with MJ. This is the NeetCode 250 series, and this is question number three from that series. I'm gonna paste the question, do the variant, also do like brute force and optimized version for both the questions. This variant is something that I found from the Leetcode discussion section, and I'm gonna try to solve it in 20 minutes along with a dry run. So let's get started. Once I paste the question, I'm gonna set a timer for 20 minutes. All right. So the question is, given two strings S and T, return true if it is an anagram of S and false otherwise. So if S is an anagram of T, we return true. Anagram is nothing but all the letters in S should also be similar in T. Okay. And I will have a few questions for the interviewer in an actual interview setting. So first being empty spaces since it's a string input. Second would be um, kind of characters in the string input. Third, we can see that output is Boolean. So if it's true, length be different of S and T, that would be one corner case. And T and size of the string input. Um, I think that would be like most of the questions that I would think of. Yeah. So for this question, we can assume there are no empty spaces in the string. And the kind of characters would just be lowercase English. And the length of the string could be from 1 to. Oh, also like fifth question would be empty string. Empty string. Okay. So here it you cannot have an empty string. It would go from 1 to let's say 10 to the power. Maybe like 5 into 10 to the power of 4. So string can be very big. Um Size of the string input would be this similar thing. An empty string? No, not in this case. Okay. Um so as we see, that A is, so for, let's take this example. So, there are two A's, N is one, and G is also one. Actually, there are three A's in here. R is one, and M is one. Yeah. So one option is that we start a pointer at I and then go all over t, um the T string and check if an A exists. And if suppose A did not exist in here, then we'd return false, but otherwise we will return true. Now, if we do that, and let's say we found A here, then it's good. Then we found N, that's good. But then now when we start the loop from again, then when this A will be counted, then this A in T string would be like that is already there, but now it's double counting. So we'll have to keep track of indices in T so that if that index has already been visited, then we will have to look further in the rest of this string. But here the time complexity would be O of n, which would be the size of t, plus O of m square, because for this t string we would be like comparing it multiple times, and space complexity would be O of m, because we will have to store every in character with its index to for a lookup. Or like even if not, we could just store the indexes and store it in the hash map. Sorry, store it in the set, because there could not be like duplicate indexes that we can use. So that is one option. But obviously, like as I mentioned, that we are repeating the steps again. So what if like we already have like a counter for S, which would be like the same thing. This is like an optimization. Okay. So if we have this counter, what we can do is we can just go over T and decrement the count of each character. So right now, for example, let's go over T. So when we visit N, let's say our pointer is here. We visit N, we make it 0. Then we come to A, then we make it 2, decremented by 1. G, make it 0, like it will be -1. Again, A, so that becomes 1. R would become 0. And now we're at this A, this becomes 0. And M, this becomes 0. Now we can just go over counter of S and check if all the frequency value is 0, and then return true or false depending. If it's all 0, then it's true, and if not, then it's false. Here the time complexity would be O of n to count S. Then it will be O of m to count, to go over, T string to check the count of S. And space wise, it should be O of 26, because at most we are gonna have 26 characters, which would be O of 1 space complexity. But this would be like a lookup eventually. So, yeah, that is one approach we could do. And in this same example, another approach is using a list. Sometimes most companies will say that, oh, hash maps can have collision and all that. So we could like use list and then initialize it with 0 into 26. So that is at most 26 characters. And then that would store the old like ASCII value of all the letters. So for example, if this is 0, 0, 0, 0, 0, 0, 0, whatever till 26, then for this is A, so here the count would be 3. And then at N, wherever it would be, the count would be 1, and so on. And then we just go over T and check like if this count, like we'll decrement it again, and if we'll check if there is any value that is bigger than 0, then return. So this is like just a solution in case the interviewer does not want like a hash map solution. But I think the for this as well, the time complexity would be like O of m plus n for time, and then O of 1 for space. The space complexity would change in case like there exist additional characters So that would change it. And now I would go with this hash map solution, and then I have to finish the variant as well. So let's quickly code it up. Um, so define valid anagram. Here, we're gonna pass in, let's say S, which is a string, P, which is also a string, and our output is also a string. No, sorry, our output is Boolean. We're just returning true or false. Okay. Um, here we can do like counter for S, which we can use a default dict to avoid any collisions, or like if the index does not exist, we'll get index issues. So it would be int value, and then we could do for character in S, counter of S at character, increase its size count by 1. I think it's just default deck. Yeah, all right. And then now our counter should look like A3 and whatever 1 and so on. That is what this would do. And now we have to go over for character in T. We'll do if character not like it does not exist in the counter, then we immediately return false. Otherwise, counter at S at character minus equals 1. Also, one like quick edge case, different length. So in that's the case, we don't even have to bother. So if len of S is not equal to len of T, just return false. And then we now we just go over the counter. So for example, there is a function which would just do val equals 0 for val in um, counter s dot values. I think that is what the syntax is. And we can just return that. This will give the boolean true or false. If value is not equal to 0 for any of the value, then it will just return false. And yeah, that should be the code. I don't think I have to try run this because I think it does solve the problem. Here we can also just use counter from collections, but I guess that might not be acceptable in the interview settings. This two line of code could change. Yeah, so that would be it. And then now getting into variant. Um, so the variant for that would be, give me 1 second. Okay, so you're given a dictionary containing valid English words, list of strings, and an input word. Return all valid words from the dictionary. So here the example is, actually, let's just do this. So here the dictionary is this, and then and this is our input auction, and we have to output all the words that contains the same anagram. So the best way right now, it's a list, right? So what we can do is we can make it into a hash map problem. And then we could do like sorted characters of words, a list of words from that dictionary that match the key. So for example, if this contains auction, so we'll have to sort it, and that would become like A, C, D, E, I, N, O, T, U, and then map it to all the other like auctioned, and then it will also be like cautioned. That is what the similarity is. And then we can just look up from this dictionary. So to process, this would be like log m, like that would be the size of the string to sort. And then we'll have to go over the entire dictionary. So that would also be m log m. And this is like just for initial sorting, reprocessing basically. Okay. And then lookup would be also like m log m. And n, I mean, we can change this to n because that would be the number of words, and this would be the maximum word length, m. Yeah. Um, so to code this up, I could do like class methods and stuff because it'll be easier. So let's call it class anagram finder. And here we can just do like define init. And we are gonna pass in word list, which would be list of strings. And the output would be nothing because it's just we're initializing it right now. So let's do self.anagram map, and we can call it default date of list, right? Because that is what our plan was. So it should be something like here. Oh, auction, and then the list of all the words that are present in the dictionary, and we'll just look it up quickly. Okay, and then we'll do forward in word list and sort. So also I think we should ask the interviewer question. So like lowercase, uppercase. Um, so here it could be both, and then also empty, not for right now. If we could add it as like follow-ups and also count in the regular questions. So what we'll do is we could just use a sorted function and um, sort the word. And this would we'll have to like make it back into a string, right? So we could just do key equals dot join sorted word. And then if suppose the word is upper, then we could make it lowercase by this. Yeah, and then we have to append this as the key. So we'll do self.anagram map at key. And since it's a list inside, we'll have to append the word. Yeah, so that is what it would do. And then we can have another function, find anagrams. We'll take in self and the word, which will be a string input. And we are gonna return um we're gonna return a list of string. And yeah, So the key would again be the same, right? For the word. So this is the key because we'll have to sort it. And now, like, check for every word if that exists. And if it's not, like, just append it to the answer. So what we can do is return this in the list, and then we can do for like W for W in self dot anagram map dot get the key, and also like if it's empty, and then we'll do if W dot lower, like, oops. Let me just finish this up coding, and I won't be able to do the dry run for this one, but I think like it should be correct on most part. That would be it. Actually, this would end here, and then we'll have to check if like is not equal to word current word that we have found in the dictionary, word dot lower, and then it would return the list of the words. Yeah, I think that was all. I think this might be a little broken, but I don't have that much time, like at least according to interview scenario. So thanks for watching.